Alright guys, so I'm going to give you a quick rundown of series circuits. Hopefully by now y'all have had a chance to watch the Edpuzzle that Coach Mott's made and answer questions along the way regarding the notes on a series circuit. So I'm just going to kind of reiterate some of that stuff that Coach Mott's talked about. I might go into a little bit more detail as far as solving for voltage, current, and resistance in a series circuit. So this is a series circuit. And here is a real life example of one. So you have a battery. Your battery is your power source. It's the source where the voltage comes from. Sometimes you might hear it referred to as a pump. And what makes this a series circuit is that there's only one pathway. So current always flows from positive to negative. So on every battery, you've got a positive and a negative terminal. So if you find the positive terminal, and follow the wire from this end all the way down. There's a switch right here, which we'll talk about later. Through this light bulb, through this light bulb, through this third light bulb, and back to the negative terminal. That makes one pathway, which is what makes it a series circuit. So if any point in this pathway, this wire becomes cut, or one of these light bulbs goes out, or someone steps on the light bulb and it breaks, what it does is it creates a gap or a hole in that circuit, and the electrons cannot jump that gap. So if this light bulb burns out, the electrons cannot go from this part of the wire to this part of the wire. They have to go through something. So if there's a hole here, a broken light bulb, then these remaining light bulbs will stop working because there's a gap or a hole in that circuit now. And that circuit is said to be an open circuit. So Ohm's law, you should have heard a couple things or a few things about Ohm's law. Ohm's law is mathematically expressed V equals I times R, which says that voltage is equal to current times resistance. And in this equation, we can see that there's an inverse relationship between current and resistance. So if the current goes up, the resistance has to go down in order to maintain a constant voltage. So three things that we're going to need to know that are very important is one, current is constant in a series circuit. So at every light bulb or every component in a series circuit, the current is always the same at every single point. The second thing we always need to remember is that the voltage, the total voltage, is provided from the voltage at each individual resistor. So in other words, to find the total voltage, you have to take the sum of the voltage at each component. So you simply just add up the voltage at the first light bulb plus the voltage at the second light bulb plus the voltage at the third. When I add them all up, then I know what the total voltage is coming from this battery. Or if I know the voltage at the battery, the total voltage, and I know maybe 2 out of the 3 possible light bulbs here, I can find the missing voltage from the light bulb by subtracting to the other side. And I'll show you an example of that here in a minute. And the third thing that you'll need to remember is that as more components are added in a series circuit, the total resistance increases. And it increases because the total resistance is the sum of the resistance at R1, R2, R3, at however many components you have. Okay, so and again, I'll show you what I mean here in a moment. So let's go ahead and look at our sample circuit here. Let me get that straight. Okay. All right, so here we've got a circuit, and this symbol right here, and I'll write this on here. This symbol represents a battery, or this is a power source. Okay, so that's a power source or my battery. VT here and here, RT, these are my total values, and you'll always find your total values at the power source or your battery here. So I know the total voltage is 12, and I know the total resistance is 60. So as I move along here, I see R1, which is my first resistor. This could be a light bulb, it could be a toaster, it could be a refrigerator, it could be basically anything. But what it's telling me at my first resistor is that that resistor has 27 ohms of resistance. So it's telling you the resistance at this component. When I keep moving here, in the second resistor, I've got 15 ohms of resistance. And in the third resistor here, which I don't know what it is, that value is undefined at this point. So we're going to set up a table to fill in all these values that are here and find the missing values. Okay. So in my table, I've got total column for my voltage, current, and resistance. At resistor 1, which is right here, I have voltage, current, and resistance. At resistor 2, I've got voltage, current, resistance. And at resistor 3, I've got voltage, current, and resistance. So I'm solving for V, I, and R at every single one of these. So Ohm's law comes in handy. V equals I times R. Okay. So what I'm going to do first is I'm going to fill in information that is given to me based off of the diagram. Okay, so when I look right here, I'm going to start with my total values at the battery, at the power source. So my first total is voltage, and it's 12. So I'm going to write 12 under voltage right there. And then my next total is resistance, and it's 60. So for RT, I'm going to write 60. All right, so I'm going to move on to the first resistor, R1, and it tells me there's a value of 27 ohms. Ohms is a unit for resistance. So for at resistor 1, I know that the resistance is 27 ohms. At resistor 2, I've got a resistance of 15 ohms. And resistor 3 is unknown. So that's all the information that I'm given at this point. Okay, so now we need to use Ohm's law and our rules for series circuits to complete the rest of the table. So one more time, I can't remember if I mentioned it or not, but I know this is a series circuit because if this is my power source and I follow the pathway, think of it like a maze. If I'm trying to complete this maze and I'm following the wire through this component here, through this component here, this component here, and back, I can go from start to finish in one pathway. That's a series circuit. All right, so let's see here. The first thing I want to do is down here. I've got, you're essentially looking for areas where you've got 2 out of the 3 possible combinations within a column. I can also fill in this value because I know a rule for my total resistance. So let's go ahead and fill in this value first. Okay, so to find total resistance, we wrote the rule, or the rule was written up above. I'll rewrite it down here for you. The total resistance, RT, is equal to the resistance at R1 plus the resistance at R2, and I've got 3 resistors, so plus the resistance at R3. So if the total resistance is 60 and resistor 1 is 27 and resistor 2 is 15, I need to find the missing value, which is R3. So in other words, 27 plus 15 plus an unknown value have to add up to 60. So you can simply take the total value and subtract 27 and subtract 15. And you'll notice that you get a value of 18. So my total resistance, my resistance at R3 is 18 ohms. And to check your work, if you take 18 plus 15 plus 27, you should add up to 60. So the next thing I want to do is find the current here. Okay, so I've got voltage and I've got resistance. So if I take Ohm's law, which is V equals I times R. Voltage is 12, current is unknown, and resistance is 60. If I want to get I by itself, I've got to divide 60 to the other side. So 12 over 60 equals my current. And when I type that into the calculator, you get 0.2 amps. Now, one of the things that we mentioned up above about current is that current is constant. So if current is 0.2 here, then that means it's got to be 0.2 everywhere else. So this is 0.2, this is 0.2, and this is 0.2. Okay? Now the last thing we need to do is find the voltage at each resistor, and that's simply, again, Ohm's law, V equals I times R for every single one of these. So I times R, we've got I, which is 0.2, R, which is 27, so 0.2 times 27 gives me 5.4. Okay, moving on over here to resistor 2, I've got I times R, where I is 0.2 and R is 15, so 0.2 times 15 gives me 3. And moving on to my last one, I times R, 0.2 times 18 gives me 3.6. Okay, and I can check my work because I know that the total voltage is the sum of the voltage at each resistor. So 3.6 plus 3 plus 5.4 gives you 12. So that is the completed circuit for the first series circuit that we have drawn for you. So let's go ahead and look on down on the next page. We're going to look at the very bottom. So Coach Mouse should have gone over this with you in the video. I'm going to go over this in a little bit more detail for you, so I'm going to zoom in on that portion first. Alright, so you have a nice clean view of it. Alright, so I'm looking at my schematic here. This symbol right here is my battery. It's my power source, so I'll label that. This is my battery. It doesn't even have to be a battery as long as it's a source of power. Okay, so that source of power could be plugging something into a wall. It's as simple as that. All right, so I've got one resistor here. So let me backtrack. If I start here at my battery and I follow the wire through the first resistor, back through here, through the second resistor, and back to the power source, that's one pathway. One pathway tells me this is a series circuit. And this series circuit has two resistors. These could be two light bulbs. They could be a toaster and a microwave. It could be a cell phone and a laptop. It could be pretty much anything. Okay, so I don't have any values drawn here. It just says R2 and R1, labeling that this is resistor 1, this is resistor 2. The values are actually here in the table here. So it tells me the total voltage, meaning the voltage at the power source, is 30 volts. So whatever this source of power is, it's supplying 30 volts of power, or 30 volts towards my voltage, or the push of those electrons. Individually, at R1, the resistance is 15, and at R2, the resistance is 10. So I'm going to just write on there that this is R1, and we'll say this is R2. Okay. So let's go ahead and begin. I know that my total resistance is the sum of the resistance at each resistor. So RT equals R1 plus R2 plus however many components you have. In this case, I've only got 2, so I'm going to stop there. So my total resistance is unknown, but I know that R1 is 15 and R2 is 10. So 15 plus 10 is 25. We got a total resistance of 25. Okay? So this is R, this is I, V, and P. So the next thing I want to do is find current. Okay? Remember, current is going to be constant. So once we find I here, we'll know where I is everywhere else. So to find I, I'm going to take V equals I times R, where your voltage is 30, your I is unknown, and resistance is 25. So when I move 25 to the other side, 30 divided by 25 gives me 1.2. So my current is 1.2 amps. And we said it's constant, so it's 1.2 all the way down. Okay. So we got resistance, total resistance, we've got current all the way down. Let's go ahead and find voltage for the remaining two resistors. So voltage is equal to I times R. So for resistor 1, we'll say the voltage is unknown. Current we said was 1.2 and resistance is 15. So 1.2 times 15 gives me 18. And my next one, which I can calculate the same way, also I know that the voltage here plus the voltage here has to add up to 30. So 30 minus 18 gives me 12. Okay. Also, if I was to take 10 and multiply it by 1.2, I get 12. And the last thing I want to do here is find the power. Now, power is current times voltage. So power is unknown. We're going to find our total power first. Current is 1.2 and voltage is 30. So 1.2 times 30 gives me 36. Okay, now I'm going to do the same thing down for resistor 1 and resistor 2. So power equals I times V. Power is unknown. I is 1.2 because current is constant. Voltage is 18. So 1.2 times 18 gives me 21.6. And then the last one I can find by taking 36 and subtracting 21.6 to get this power. Or I times V, 1.2 times 12. However you wish to do it. I'm going to keep the same way. P equals I times V. Power is unknown. Current is 1.2. And voltage is 12. So 1.2 times 12 gives me 14.4. So I got 14.4. One way to check your work. 14.4 plus 21.6 equals 36. 12 plus 18 equals 30. Current is constant. 10 plus 15 equals 25. And now we've completed all the information for my series circuit. So hopefully this information helps. Use this little brief tutorial, this explanation to help you with the circuit practice in Google Classroom.